Hey everybody, welcome back. Today we're looking at another Magnepan upgrade. This time the 2.7i. And I have to say this one for me was a little more difficult. Not because the speaker itself was difficult, but I spent a lot of time on this really looking into some better solutions and trying to figure out ways to take this yet to another level. And there were some things that I'll talk about in a few minutes that to me just aren't right in the way that these multi-way Magnepans are designed, where any of the three-way models are not done in a way that I would do them, and it's causing some problems. And I tried to solve that with this one, and I wound up with something pretty special, and I want to talk about a little bit about that in a few minutes. But first, I want to get to the guts of this thing and kind of how it's made and how it measured and look at some of those things. First of all, three-way model, big ribbon tweeter, and I really like their ribbon tweeter. One of the things I like about it is it'll play down really low. Like this thing will go way down there to like 200 hertz or something. And so there's a lot of flexibility there on it with a driver that has the capability of going down that low. I want to say also too that they let the tweeter play down pretty low in this one, really a little bit too low. But the benefit that I've seen in this one versus other models, especially other three-way models where drivers are just playing on top of each other and they're playing the same ranges, when that happens, as you move left or right, you're creating more of a time delay from one driver to the other because they're playing the same wavelengths. Now those wavelengths line up out of phase, and so you may have this experience with listening to some of the bigger Magnepans. If you move one seat over left or right, suddenly you've created a large amount of comb filtering in different areas. And maybe the speaker on the left, you've created a big hole in one place in a peak, and then the speaker on the right, it's where that one was a peak. This one now, that one's a hole, and there's a peak somewhere else. They're causing big comb filtering cancellation effects and peaks. I didn't see that at all with this one. With this one, with the tweeter playing down pretty low, and it looks like they put enough filter on the bass and mid drivers that they're not playing on top of each other too much. And as I took a room response and I started tilting the speaker, 10 degrees, 20 degrees, 30 degrees, 40 degrees, and I did it in both directions, it looked good in both directions. It maintained an even response. So as you move left or right, this particular model, it'll maintain a pretty good response. Now, I don't know if that's something new that they've worked on, because I've talked about this in my videos before when I do upgrades on the Magnepans. I don't know if this is like a whole new design approach that they've taken that has resolved that or not. Or maybe they've been doing it for a long time on this model. I don't know, but they did a good job in that regard. Now, parts-wise, as you know, the back plate on these things are this little steel plates, and they've got fuses. I got a fuse on it, and all the parts are ferrous, and there's like a little ferrous loop that goes from one to the other that connects the tweeter driver to the rest of it, and there's little steel set screws that you have to loosen up with a little Allen wrench to get your bananas in there and then tighten them up, and it's just, there's a lot of crap in the signal path that is just really mucking up the sound. I really hate that. Parts-wise, they had a small laminated iron core inductor, which is a good quality inductor. I know where those inductors come from. And it's good quality, but it's playing well up into the mid-range. And anytime you've got a driver playing well up into the mid-range, it's always better to use an air core than an iron core. Those iron cores are great for like below 200 hertz or so. So it's like, okay, caps wise and resistors, it's like, okay, there's kind of some cheesy parts in there, and then there's a poly cap or so in there, but parts wise, fair, but overall it just makes me want to hit my head like, man, come on. Let's look at the frequency response measurement that I took, which was the best one I could get out of it from, I want to say I was 8 feet away in the room. So it's a room response, and you have to measure these that way. You have to take into account the floor reflections. It's there with every speaker. So looking at it overall, it's not bad. And again, like I said, when I moved left or right, it looked good in all directions. Now there was a big peak at 600 hertz. They're kind of crowned up right there, and yes, the drivers are overlapping onto each other too much there. Also, I want to hold that up there. Hold that frequency response, and right below it, let's put the frequency response of the individual drivers that I took once the crossover was removed. Note there's a purple line there that's the tweeter. Then there's a blue line there that is the base panel, which is the furthest from the tweeter. The tweeter's actually here. The one to the furthest side, that's the base panel. And then there's a mid panel right in the middle that's a little bit thinner. That's the green line. So you can see its sensitivity is down from the base panel just a hair. Now look at the tweeter's response. There's a reason I wanted both those up there together. Look at the purple line, and you can see that the tweeter has kind of a big crowned area there, a peak that's around 700 to 800 hertz. And then if you look over at the frequency response of the whole thing, right there at 600 hertz, you can kind of see the same peak. Like, okay, that tweeter is getting up into that range. It's still pretty crowned up right there, like it's sloping up, and then it's dropping off. So it's getting down there pretty low. Into a range, it kind of makes me worry that it's stressed a little bit. Anytime you play those ribbons down low, they'll play low. But when you start putting a lot of power on them, because let's face it, the sensitivity of these are pretty low, you need to put a lot of power on there to get those levels up. And then the tweeter gets a little stressed. Anytime you're forcing it mechanically to move and it's getting in and out of the gap, it's kind of losing control when it gets up into the higher levels, or you get higher power levels on it. Of course, their solution to protect it is to put a fuse on it so that if you start to overdrive it, you'll just pop the fuse. The real solution is to pull it down out of those lower frequency ranges, minimize its mechanical limits, or minimize its mechanical movements, and now you can put quite a bit of power on there. Electrically, it can handle power just fine if you're not stressing it. So I always look to kind of get that tweeter back away from those ranges and let the drivers cross into each other so that they're staying in their own ranges. That way when you move left or right, you're not changing time arrival in such a way that they're playing the same frequency and now one's delayed versus the other and causing a hole. So the next thing, well, let's look at a couple other things first. Let's look at the spectral decay, and you'll notice it's pretty choppy, and there's a big hump in the area down there around 600 or 700 hertz where either the tweeter's playing down there that low and there's stored energy there from the tweeter going down into that range, or the mid-bass panels are just on top of each other right there. There's a little bit of stored energy there, a little bit of something going on there shouldn't be going on. And then at 3,000 hertz, there's a pretty good little ring there. There's a lot of little choppy rings, but the one at 3,000 extends out there quite a bit. Looking at the impedance curve, it's a nice flat line, just above 4 ohms, and then it drops to 3.2 ohms at the lowest, which is around 3,500 hertz or so. So, okay, the measurements, they are what they are. Now, here was the conundrum, and here's why I'm wearing my I'm difficult shirt today, because this thing was difficult. The base panel and the mid panel are on the same diaphragm. Same exact diaphragm, just one has a group of elements down one side, one has a group of elements down the other. It's a thin aluminum foil that's attached to the diaphragm. So effectively, they're not really two different drivers or two different drive panels. It's on the same diaphragm. It's like having a woofer with two voice coils. It's not two separate drivers. It's just two separate coils on the same diaphragm. That's exactly how this thing is. And I noticed that with the 3.7 eyes that I worked on. And it's like, oh, crap. It's like they needed to be a strip down the middle where it was an attachment point where one couldn't move without affecting the other. In other words, where they were completely separate elements, where the movement of one was completely separate from the movement of the other. Then there would be two separate drivers. If they would just put something on there and attached it so that the elements were completely isolated from each other. But they're not. The whole thing is one big diaphragm. And And I worked with that some on the 3.7i, kind of brought the level of the mid way down so that it wasn't so affected, and I let the tweeter cross to it, and it kind of made a filler driver concept. Thinking back about that now, I think there's a better way I could even do that, and I did it with this model. It's like, okay, if they're the same diaphragm, then I need to treat this thing like it's one element. Because any amount of crossover parts that you put on there causes some shift in phase. So it causes a little bit of a delay. So now you got a base panel that's affecting the mid panel because it's the same diaphragm. So the whole thing is being affected, and it's not going to work out very well. Now I could treat it like it's just one big driver, one big element, in either series or parallel the connections, but then it's this wide, and the acoustic centers between the tweeter and that panel start getting a little further apart, which means you have to cross it over even lower so that when you move left or right, you're not changing the time arrival and causing holes at the crossover point. It's like the tweeter really needs to cross to the mid panel, but the mid panel is attached to the base panel portion. So it's like it's creating a little bit of a conundrum there. I want to keep this whole thing in phase. In other words, I don't want one to be moving independently of the other at the same wavelengths and causing a shift in phase, which is kind of what's going on with this design. So I can't parallel the drivers or parallel the elements because the impedance would drop down to 2 ohms. I could series the elements. The sensitivity would be the same in a way, but the two are sharing the load, and it would shoot up to 8 ohms of impedance. Now, if I did that, I know there's a lot of guys who would say, well, I used to have my dial set at 12 o'clock setting, and now I'm having to turn it up to 1.5 to 2 o'clock setting, or 1 to a 1 o'clock setting to get the same output level. So it lost sensitivity. Technically, that's not true. If you've got a receiver, a solid state amp, it's just changed the impedance. So the power is the same to get the same sensitivity level, but where you're setting the dial is going to be different. In other words, if you had it set straight up before, it was at 50 watts because it's driving a lower impedance load of 4 ohms. Now you're setting it up to a 1 o'clock setting or higher, and it's still 50 watts. In other words, the output is the same as it was before, but it's driving a higher impedance load, so you're having to turn that gain up further for it to reach that same power level. Because most solid state amps, they'll if a good one will double the amount of power as you half the impedance. But at the same output, like at the same 1 watt, the sensitivity would still be the same. They're just sharing the load. So I could do that, but then again, the acoustic centers would be in the middle. So I thought, I got an idea. How about if I treat this like it's a 2.5 way design? Like I do a lot of the designs where I've got woofers like that in series, and I'll bypass the lower woofer with a big cap value. In other words, what happens is the high frequencies will pass through the cap and go to the upper woofer that crosses the tweeter. And as frequency goes lower, they're in series with each other and they bypass the cap and they both play together. And if you look at the frequency response of the individual drivers, let's pop that back up again, and you look at the blue line and the green line, they both play down pretty low. I mean, they're both playing down kind of the same bass level. They're on the same diaphragm. So treating them the same in the bass is fine. In other words, the bass going through this section of elements versus that section of elements, it's not going to hurt this section of elements. They're both the same. So it's not like you're taking a mid-range panel and making it play low bass. It's the same panel. So I series the two elements, and I put a coil on there that made a beautiful slope. Nice, it looked clean. And then I started bypassing it with different values of caps, bypassing the bass panel so that as frequency increases, only this portion of the panel is crossing the tweeter. But as frequency decreases, the whole panel is playing together. It worked great. It's like, okay, that looks good. It's got a smooth response. The whole panel's playing together. There's no shift in phase. So one panel's not trying to move independent of the other in a different direction. The whole thing moved linearly over the entire range. And so let's look at the crossover that I was able to do with this thing. And it's crossing at, about 740 hertz. I pulled the tweeter back to keep it out of a really low frequency range, and that worked really well. Now, if you look at the very top of the tweeter's range, you see a pretty good little peak up there. As I moved different distances, and you move heights up and down a few inches, that moves around a little bit. I could have moved it around in the room and got a better response, but that's not what I'm looking at here. I mean, it is what it is. I can't really change that up there, and your in-room response is not going to look like that. It's going to be a nice smooth roll-off. That's indicative of exactly where I had it placed, where the room reflections were, and all that kind of stuff. Let's look at some comparisons now. Let's look at the spectral decay now versus the spectral decay where it was. Notice now with those base panels playing together and the tweeter's not getting down into the base panel, notice how much cleaner the spectral decay is. Notice how much cleaner it drops off. Drivers aren't working against each other in the base panel anymore. They're playing linearly. Look at how clean and how fast that thing is. And we lost that stored energy at 3,000 as well. So the overall response of this thing, lots cleaner. And as I moved left, all the way left and all the way right, it still looked really good, especially 20 and 30 degrees off axis. Nice clean response. 30 to 40, starting to move around a little bit in both directions, but overall, the off-axis response looks great. Let's look at the impedance curve now. Now you'll see it's a pretty even, flat 8 ohm load, and it drops to a minimum of 5.9 ohms down at the tweeter end. And that's because there's also a resistor in line with the tweeter now, bringing that impedance up and balancing things out a little more. And a couple of other things too. When I did that, it was a low order filter, and so there was a pretty good impedance rise in the middle where there was actually a crossover point. I thought, it'd be cool if that was really a more linear impedance response, nice flat line. So I put an impedance trap on it and brought that down. So one of the reasons you see a nice flat line there with just a nice little wiggle there, really flat impedance, is there's an impedance trap at the front of that network that's balancing that whole impedance out to where your amplifier sees a consistent load. Much like it was before, the way these are designed before, the drivers are more playing on top of each other, so you're not seeing a reactiveness of the crossover in between, keeping them in their own ranges. They're just overlapping on top of each other, so the impedance is flat. It's like they designed it based on the impedance curves. Whereas I'm looking at the acoustic output of the elements, keeping them in their own range, and then I used an impedance trap to make that nice flat line. So your amp sees the load real consistently, and it's more an 8 ohm load. So if you have a big tube amp you want to use, tube amps now suddenly are going to like this speaker. It's a lot more friendly load and a lot easier to drive. So that's a plus. Again, if you've got a solid state amp on this thing and you thought, well, I had my volume at 12 o'clock, now I'm at 1 o'clock. No, you didn't lose sensitivity. The sensitivity is practically the same, but you will turn your dial further up to output the same amount of power because the impedance is higher. Remember that. So don't think, oh, it lost sensitivity. The sensitivity was already pretty low. Sensitivity's low on these anyway. And the measurements that I'm taking, I'm pretty far away, and I'm adjusting the output levels. So the measurements that you see here are not 1 watt, 1 meter outputs. So you can't really go by the sensitivity measurement that you see in the measurements as to the actual true output levels. To see that exactly, I'd have to get back to 1 meter to see the level at 1 meter. But this being a big panel like a line source, that really doesn't tell the whole story. It only loses 3 dB per doubling of distance until you get out of the near field, far field transition area. And then it starts losing 6 dB per doubling of distance. So you don't lose output as you move distance away from it like it does, like you would a point source. So output levels are a little higher than what it would actually measure 1 watt, 1 meter. Now, parts quality coming up really high. Big air core inductor on the woofer mid panel, which I guess really is now just a woofer panel. Sonic cap in the tweeter circuit. Our resistors, good quality parts. Not a high order filter. There's a big cap that's bypassing the base panel on there to send all the highs to the to the mid bass section of this thing. So that's a big polypropylene cap, and there's a little 0.1 bypass cap on that. So good quality parts throughout. Also, the worst thing about these Maggies, the thing that just kills me, that metal plate with all the ferrous material in it. With this kit, this upgrade, you're going to get a 3D printed new back plate to hold tube connectors. Best quality connection there is. And I'm pretty sure all of the crossover parts for this one should fit in the bottom of this speaker. You may have to get a little crafty with trying to get all the parts in there, but I think they're going to fit just fine. Now, if you want, and some of you guys do, want to put the crossover external, then we'll do the kit with one of these panels. Now, these panels have 3 sets of tube connectors, or 3 pairs of tube connectors on each one. So you can wire the driver's panels straight to each one of these things, and then you can mount your crossover external with just one set of tube connectors going into it, make you a little box for it, and then run your wiring straight out that little box, put your male tube connector ends on so you can plug them right in, and you can mount your whole crossover external. Then if you want later, it's easy to tweak and mess with it when it's external. That's what I like about it, especially these things because of the socks. Oh, don't get me started on the staples. Man, but if you can get the staples out of this thing, that's the hardest part. That's the part I hate the most. So if you can get all that done, you're really home free. The actual upgrade of the parts is not that big of a deal. It's not a problem. So that's it on this one. I know I drug this out a little bit because this one presented me with some challenges that I wanted to fix, and I'm really happy with how this turned out. And I think any of you guys that have this model, this upgrade is a must-have upgrade. Like, this is going to really transform this speaker in clarity and detail, and just the way it sounds, how open and transparent it is. It's going to go up by a lot. So must have if you have this model. So that's it for this one. I hope you enjoyed the video. Thanks for watching, and see you guys in the next video.